Hey Valley Middle, welcome back to another math video. Tonight we're going to be working with function tables and completing them. Before we do that, let's take a look at our trivia question for the day. How many different pizza combinations can Domino's make? We'll be back with the answer to that after instruction. Tonight officially our target is I can complete a function table. Let's do this thing. Here's a function table like one you might see in the quiz that you have to complete. In this one here, we've got x values. We've even got some examples of the functions, and we have one y value. So we know that 1 is our x value, so we plug 1 in place of the x in the function, so 3 times 1 is 3. When x is 2, 3 times 2 is, we'll go over here to our number bank and grab 6. When x is 3, 3 times 3 is 9 from the old number bank. Now we've lost the function, but we still know what the pattern is here. It's 3 times x. If x is 4, it's going to be 3 times 4. And that equals Uncle Fred. Actually, that equals Uncle 12. If for any of these boxes you thought Uncle Fred was the correct answer, I need you to stop the video, tell your parents you need to seek immediate medical attention. There might be something wrong with you. All right, taking a look at our vocabulary, just a quick review. We've got the domain, which is over here. This is the input or the x value. You've got the range, that's the y or the output, and the functions in the middle. That's what happens to the x to get to the y. Let's take a look at one more example together, and then I'll have you try a couple pause problems on your own. Complete this function table. Well, you look at it, and let's pretend we don't have no idea what's going on. So we just think about, what does it look like is going on? We'll go from 1 to 3. It could be 1 plus 3, or 1 plus 2 to get to 3. Yeah, that works for this one, but take a look at the next one. 2 plus 3 is not 6. So what I'm doing here is I'm trying to figure out what's happening to the x value to get it to y. And I came up with a rule which was plus 2, and I tried it in the examples. And if that rule doesn't work, then you go back and try a different rule. If your rule does work, go on and try the rest of the values. So it looks like this is times 3, times 3, times 3, times 3. All right, so we know that our rule is 3 times the x value. So we can fill our table in here. 3 times the 5 would be the 15. 3 times the 20 would be the 60. 3 times 99 is going to be 297. Here's the tricky one on here. They call it the nth term. And I'm just going to squeeze a little nth in here. So for the nth term on this one, that means any term that you can think of. Well, it would just be 3 times the x value would be the nth term. So the y is equal to the 3 times the x. Pretty simple, right? All right, I think you can handle it. Let's try a couple of pause problems. Try this one. Complete this function table. See if you can figure out what's going on. Try the rule. If it works, try it for some other values. See if it works for all of them. If not, come up with a new rule. All right, my first thought was that this one here would be times 16. 1 times 16 is 16. 2 times 16 is not. So, that rule's not going to work. So then I tried, how about plus 15? 1 plus 15 is 16. 2 plus 15 is 17. 3 plus 15. 4 plus 15, I've got it. 5 plus 15 is 20. 20 plus 15 is 35. 99 plus 15 is 114. The old nth term here, the old nth term, well, you would see, so just take any term, any x term, and add 15 to it to get that nth term. So the y is equal to x plus 15. All right. One more for your pause problems here. Give this a shot. Okay, let's think about this. The first thing I thought of was times 2. Because I saw 2 times 4, but that doesn't even work for the 1 value, so it can't be that. It can't be times 3, but I saw that one there, so that didn't work. Then I started thinking, well, could it be x squared? Well, 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared is 16. I got a pattern here. 5 squared is going to have to, I'll have to send this to the back here real quick. Order, send to the back. 5 squared would be 25. 20 squared would be 400, 99 squared would be 9801. And again, the old nth term is whatever x is, you square it. So the y is equal to the x squared. Okay, it's time for the ticket to the show. Just a couple of them here. Fill in these charts. You got 5 question marks up top here. And here, you've got just one y value you need to figure out, but you need to figure out what the function is. Okay? Very good. Let's see. Answer your old trivia question. How many different pizza combinations can Domino's make? Well, you have to start thinking about the toppings and the sizes. They have 4 different sizes. They have 4 different pizza bases. And this information is probably actually a few years old, so it's probably even more. For double toppings, you can add 4 choices. For cheese, there's 3 choices. There's something like 44 different topping choices. It just gets incredible. I used to think it was 75 million, but there's actually about 105 million different types of pizza to choose from at Domino's when you factor in all the different toppings, the sizes, the sauces, if it's a single topping or double topping. And if it's the double topping of the same topping, jinkies, you could be eating pizza for quite a while. Thanks for listening. Bye.